Good morning. We have been spending about 20 minutes working on our project, wrapping that up for the ones who had not finished yet. Then we took a magnifying glass and we kind of played with it in and out to see how it worked and magnify it, because we start telescopes today. We're talking about that. You'll be on 118. Won't be any homework questions or anything tonight, but there will be tomorrow night. So all you got to do is watch this little silly video and work on your project if you're doing one, and you'll be up to speed. Okay? All right. So let's talk about telescopes. Okay? We got roughly 15 minutes in class time. Okay? All right. It tells us how ancient people often gazed up in wonder at the many points of light in the night sky, but they could see very few details with their eyes alone. Okay, no different than you right now. If you walk outside at night and you look up, you might be amazed at all the stars that you can see up there, but you can't really see great detail. Okay? It was not until the invention of the telescope in 1608 that people could observe objects in the sky more closely. Recall that the telescope is a device that makes distant objects appear to be closer. We all know that, okay? So it actually really trumped up the studies of the planets and the stars and all of that as soon as this thing is invented, okay? And scientists have had a tool that now they have a tool that allows them to see many objects in space for the first time, okay? Galileo was not the first to use a telescope, because he didn't invent it. We talked about that. But he soon made it famous. Okay, he turned a homemade instrument into something that now people could actually get out and really start exploring what was in space.
Well, NASA has telescopes, but they're like 3,000 more times.
And was NASA around during Galileo's time?
Holy no.
Okay, then you probably couldn't go to NASA and use one of theirs.
No, I'm saying nowadays, like everyone uses it.
Very good. If only that's been what we was talking about. Okay. All right. With his telescope, Galileo saw things that no one had ever dreamed of. He was the first to see sunspots, Saturn's rings, and the 4 large moons of Jupiter. Galileo could see fine details such as mountains on the moon, which could not be seen with the unaided eye. Okay? Since Galileo's time, astronomers have built even larger and more powerful telescopes. And these telescopes have opened up a whole universe of wonders that would have amazed even Galileo. But Leo is right. Now we have, universities that has big astronomy department, has massive telescopes. GTEC even got a really cool one. I don't know if they'll let you do it right now or not, but because of COVID, but you could, like on Friday night, they would have basically a family night that you could go down and just, you could walk in and they would let you look through the big telescope and all. So,
I thought that was built for college.
what did I just say? Different colleges got one. GTEC's got one that you can actually, they let you use. Okay, seriously. Yes?
Isn't it like the farther apart the lenses, the greater you can see?
It depends on
Yeah,
the type
because
of
if you have the
telescope.
lenses so close, you can't see anything. But these little handheld ones, you would never see up, into the star.
Well, no, you would never, like the one I have back there is a little refractor. We're not going to see Pluto with that. No.
Yeah, that's why
But
you see
that's
on
not
the
what it was
picture,
designed for.
Yeah, that's why it's so long, because the greater distance,
Yes, yeah, the bigger the telescope, the bigger the lenses and all, the more, absolutely better. The farther you can see, you're absolutely correct. Okay? You are absolutely correct. Okay. Now, the electromagnetic radiation, to understand how telescopes work, it's useful to understand the nature of electromagnetic radiation. Light is a form of electromagnetic radiation, okay, or energy that can travel through space in the form of waves, okay? We've talked about waves before. We'll talk about them again in this. We will talk about them in light and sound. We will talk about them in mechanics, motion. We will talk about it in marine biology, okay? A lot of things travel by waves, light and sound being two of them, okay? Many objects gives off radiation that we cannot see. For example, in addition to the reddish light of a glowing electric heater, that heater also gives off infrared radiation. You feel the heat, but you can't actually see that, okay? Radio transmitters produce radio waves that carry signals to radios and television. But again, we can't see those waves, okay? Objects in space gives off all types of electromagnetic radiation, okay? The electromagnetic spectrum, as you can see here down on the bottom of the page on 119, okay? It shows you the distance between the crest of one wave and the crest of the next wave is the wavelength. Okay, we have talked about that a number of times already also. You know, where any wave, be it water or whatever, okay, you got the wave going, is where it crests, is right here. That is the wavelength. It's the time it takes for that to crest again. Okay, and that, they give a measurement there, and that is the wavelength. Okay, sound's going to be traveled like that, light travels like that, but they do have different principles to them that we'll get into a little bit later on. Yes, Caleb?
So like a thermal vision, it works by like taking out those radio links so you can see them. Because if you've ever seen one, like if you want like to do thermal vision, like isn't like the red and that, I mean,
We have goggles that we can pick up infrared, the heat, a body giving off heat, yes. We do have that. We absolutely do. Okay. Forms of radiation, scientists call the light that you can see visible light. Okay? Visible light is just one of the many types of electromagnetic radiation. Many objects gives off radiation that you can't see, which we talked about already. But the visible light, the electromagnetic spectrum, okay? Let's say that this entire whiteboard is the electromagnetic spectrum, okay? We can actually see with our eye somewhere around that much of it. Okay? There's a very small area that we actually see.
wow.
Okay, the rest of it we can't pick up the lights. Okay, either the wavelengths are too close together for us to pick them up, or they're spread really, really far apart. Because you will have gamma rays will be just really close together, and then you got radio waves that will be the length of a football field, or larger, okay, longer. So it varies. So we can only see a little bit of it. That's why the Bible talks about in heaven you will see colors that you have never seen before. We got colors here we've never seen before. So it'd be pretty cool. Yes.
So like the closer it is, like the more you can see.
Well, we can only get, no. If it's really close together, you can't see it. If it's really far apart, you can't see it. There's only a very small spectrum that we can see.
I can't remember which one it is, but I know there's like this super high-tech camera, and it's like a gamma camera that can see.
Yeah, I'm not saying that we don't have equipment that we can see it. We're talking with just with our unaided eye.
Yeah, I know. There's this like university there
Otherwise we wouldn't know
they
it
have
existed.
this gamma telescope that can see light traveling through objects. That's how like high tech it is. They can see like light traveling through objects.
Okay, we talked about all the cool stuff we have that we can see, all the stuff that we can see with the unaided eye. All right. So it is measured in wavelengths. Visual light has a very short wavelength, less than 1/1,000,000th of a meter. Some electromagnetic waves have even shorter wavelengths. Other wavelengths have much longer wavelengths, even several meters long. If you shine white light through a prism, then the light spreads out to make a range of different colors with different wavelengths, and that's called the spectrum. Okay, the spectrum of light, visible light, is made of the colors red, orange, yellow, green, blue, and violet. Okay, anybody know the little saying, the little name that helps you remember all those colors? Roy G. Bell. There you go. Okay. The electromagnetic spectrum includes the entire range of radio waves, infrared radiation, visible light, ultraviolet radiation, X-rays, and gamma rays. Everybody know what gamma rays does to you, right? It turns you into the Hulk. Come on.
I was just sitting there.
Yeah, turns you into the Hulk. All right. Well, that's about all we're going to cover today. We will get into telescopes tomorrow. We'll have some film clips to watch, some little videos. I'm still trying to decide whether or not to set up the microscope. I would like to set it up so you guys can kind of look through it, but I need to check to make sure just use everything happens supposed to be wiped down and all that. I'm not sure how feasible it's going to be to set that up and let you look through it, have to wipe it down. Somebody else look through it, have to wipe it down. That could take forever to accomplish. Stay tuned for the exciting adventures of sixth grade science. Bye.